Hello there, math fans. We're talking about functional notation in class, so I just want to do one more example. We did several of these in class, but the question is, you're given a function, you want to compute this weird thing we call the difference quotient. What happens? So I'm going to do step one, and I'm going to give a little bit of motivation, and then we'll finish it. So step one is you're replacing this x by an x plus h. We talked a lot about functional notation, so if you missed class, watch that again. That right there that I just wrote is f of x plus h. So I like to put those in parentheses. Sometimes I like to use square parentheses simply because I've already used the other type of parentheses. And then we're going to do minus, and then we're going to do f of x. That's what these instructions are saying. So some students have a tough time with that, but this is fairly easily remedied by asking. You really have to do this hands-on. And then we're dividing all that by h. So again, and the other thing I see students get mixed up on is they just don't realize this is what's given. These are the instructions on what we're going to do with what is given. And we talked about that a lot in class. We did it several different ways. That's it. Now, briefly, before I finish this off about the simplifying, this comes from the following idea. So that picture I have there, I'm showing, shows what this actually is. So f of x plus h minus f of x is that rise. It's that red length in the graph. And h is the orange length. If you think about like tweaking this, you get this, if you take the ratio of those two, you get the slope of that green line. It's called a secant line. Now in calculus, it's all about what happens as h gets closer and closer to 0. We call that the slope of the tangent line, which is really valuable because it allows you to find when the slope is 0 and do other things. And you learn a bunch of shortcuts. Okay, so we really would like to know what happens when h is 0, but we can't plug in h equals 0. So this question is really about, can you clean that up? So besides step one, which is to know the functional notation, step two is to clean that up. And my college professor said, we're going to take a sad song and make it better. So I'm going to turn a song on. And let's do it while we're doing this. You will start to make it better. I'll explain. So I distributed, I expanded. Any of those little bits of algebra, great to practice, great to come ask. Ooh, that looks bad. But if you do it right, everything that comes out of this goes away. And here we go. We start making a sad song better. Oh yeah, wholesale cancellation. And then what do we get? Make it better, better, better. Wrong part of the song. Okay, then which one do we divide? It's a fraction. It's too distracted by the song. Hey June. Okay, here we go. So that's this expression. That tells me the slope of this secant line. It gives the general pattern. It's not that hard to find that, but for some people it's kind of a big thing the first few times they do that. If you replace h with 0, you get what's called the slope of the tangent line. And I'm not supposed to say it, but I'm going to say it. That we call the derivative. We put a little prime here, and it's 2x minus 7. Later on, you learn shortcuts to get there, but they all come from this same place. Very important for our calculus course. I hope that helps.